This lesson is about momentum. So before we get started, I want you to have a look at this picture and think of the question being asked. Why do you think it is a good idea to avoid large objects moving quickly? So by the end of these lessons, not only will you be able to answer the question you've just been thinking about, but you'll also be able to define momentum, explain and apply the conservation of momentum, and to explain how a resultant force acting on an object results in a change of momentum and how you use this to calculate the force exerted on an object. We will only be covering the first of these objectives in this video. Right, so let's start by thinking what momentum actually is. You've all heard of the word momentum. It gets used all the time, and it gets used when thinking about objects that are moving. So quite simply, if an object is moving, it has momentum. Okay, and you can think of it in terms of how difficult it is to stop that moving object. So imagine you're walking down the road and you need to stop. To come to a stop when you're walking is very easy. However, what happens if you are running down the road? It's a little bit harder to stop. If you need to stop in a hurry, if you're running, you may well fall over. And that's the difference in momentum of the two situations. Okay, so looking at this slide, you've got two cars which have the same mass. One of them is travelling faster than the other one. And it's the faster car that has the most momentum. Now let's look at both cars again. What happens if they are travelling with the same velocity? But this time their masses are different because one is full of luggage. Which one's going to have more momentum? The heavier of the cars. So when we're talking about momentum, there are two factors that will affect the amount of momentum an object has. Its mass and its velocity. And that's why as well, when you think about lorries or big trucks, lorries on the road, it's much harder for one of those to stop than it is for a car. So knowing it is the mass and the velocity that affect the momentum of an object, we can put that together to form the equation. And the momentum of an object can be calculated using the equation where momentum equals mass times velocity. So mass is a quantity we use all the time, and that is the standard unit for the mass is the kilogram. Velocity is also one of our standards, and it is measured in meters per second. Momentum is a new one for you, and momentum doesn't have any fancy units. It is quite simply made up from the equation itself, and I've gone through this with you in the past. So because momentum is mass times velocity, the unit of momentum is quite simply made by multiplying the units of mass and velocity together. So that gives us the kilogram meter per second. So before you start using the equation, we're going to just consider one last thing, and that is whether momentum is a scalar or vector quantity. So if you remember, a scalar quantity is one that has magnitude only. A vector is one that has magnitude and direction. So let's consider momentum. So momentum, as we know, the equation, it is defined by mass times velocity. Mass is a scalar quantity, but velocity is a vector quantity. And because velocity is a vector quantity, it makes momentum also a vector quantity. So you must be careful when doing equations, not so much in today's lesson, but your next lesson, you must take into account the direction the objects are travelling in. And you will normally denote this using a plus and a minus sign. So a plus will mean moving in one direction and a minus moving in the opposite direction. Okay, so finally a practice example for you. So an aircraft carrier has a mass of 1 million kilograms and a velocity of 15 meters per second. What is its momentum? So as you know, momentum equals mass times velocity. So that gives us 1 million times 15. Therefore, the ship has a momentum of 15 million kilogram meters per second. Right, what I would like you to do now is work through the relevant page in the physics equation practice booklet. Before you do that though, just make sure you're happy rearranging the equation so that you can use it to find mass and velocity where needed. If you do have any problems rearranging the equation, please drop me a line and I will answer any questions you have. I have also recorded a video on rearranging equations, so you can look back at that if you need to.